Hey everybody, it's Mr. Carr again. Today we're going to be looking at 1.5 day 2. A little bit of parent functions and transformations, but also we're going to be focusing on how that can help us with our graphing of piecewise defined functions like this. So as a reminder, piecewise function is one overall function that's split up into 3 different sections, and it depends on the interval that you're looking at. So you see here we have the 3 intervals. We got less than 0, from 0 to 2, and then greater than 2. So we get 3 sections, but we have 2 critical values. To help graph this, I think one of the best things to do is kind of make this little table I made here. Okay. First thing is my critical values of 0 and 2. Okay. I'm going to graph this at both of these sections and then both of these sections. Otherwise, all the other spots are just going to be blank. Okay. Or I shouldn't say all the other spots, but I'm going to like where things don't exist, I'll say. So for example, let's color code this a little bit. Go with green for the first one. If I plug in -2, -2 is less than 0, so that's going to go into the first function. So it's going to go right here. -2 plus 2 is 0. Absolute value of that is 0. So -2 is going to give me 0 there. -2 does not exist on the other 2. So we can actually just scratch off this section here. And then same thing with this one. Okay, they don't exist there, so I'm not even going to plot those. Additionally, if I look at -1, the same thing is going to happen. It doesn't exist here, and it doesn't exist here. Okay. In fact, the first time I want to look at the red one is when it gets to 2 here. So I'm actually going to just do this. I'm going to scratch off all of this all the way until 2. Okay. I'm not going to plot those either. For my blue one, though, or let's go back to green. Let's finish that one. So when I plug -1 in, -1 added by 2 is giving me a +1. Absolute value of that is 1. 0. 0 is not actually part of this first one. However, to help me with my graphing, I need to know where it is on the graph. So I'm going to go ahead and plug that in. I got 0 plus 2 is 0. Absolute value, 0 plus 2 is 2. Absolute value of that is 2. Okay. This is crossing over to the next one, though. 0 is less than or equal to x here. So 0 is actually a part of my second graph. I'm going to go ahead and get blue. We do the absolute value of 0 with that one. 0 minus 2 is going to give me a -2 here. Okay. So green graph is now done. If I look at 1, 2, 3, 6, it does not exist for anything else. So I'm just going to go ahead and block that out. It's all we don't need to do any of those. Okay. So now let's look at blue. 1 is going to go, it's right in the middle of 0 and 2. So I got the absolute value of 1 is 1, minus 2 is, a -1. Okay. 2 is still a part of this one. So the absolute value of 2 is 2. 2 minus 2 is 0. So I have that point. When I look at 3, 3 is not part of this at all, and it's not one of my critical values. So I'm actually just going to scratch this off. This is done too. All right. But now I can get to jump over to the next one, our final function here. 2. So 2 is not a part of this interval, but I still need it for my modeling, for my graphing purposes. So I'm still going to find that value. So I'm going to go ahead and plug that in. I've got 2 minus 2 is 0. Square root of that is 0. Plus 2 is 2. Okay, let's do the same thing with 3 and 6 now. And you'll see I picked 6 because it makes a nice perfect square here. 3 minus 2 is 1. Square root of that is 1. 1 plus 2 is 3. 6 minus 2 is 4. Square root of that is 2. 2 plus 2 is 4. All right, so now I need to get to plotting everything. Let's start with the green one. Okay, I chose -2 as my first value. It's going to go -2, 0, and -1, 1, and then 0, 2. Now, when I go to 0, 2 right here, remember, since it is less than 0, this x value right here does not actually exist. This is not a part of the graph. At this point, 0, 2 is not a part of the graph. So to demonstrate that, instead of putting a dot, I'm going to put an open circle on that spot. Okay, that's a hole in the graph that we make sure that's clear, that's separate from the other ones. Okay, now when I graph this, it almost looks like it's just going to be a straight line, and it's close, but remember it's an absolute value function. So based on our transformations, take a look what's happening here. With a +2 on the inside, my parent function is going to move 2 spots to the left. So that means I should have a V shape. It should be coming right back up here. And I can confirm that by just kind of plugging that in real quick. If I do -3 here, that's -3 plus 2 is -1. Absolute value of that is 1. And that's that point right there. Okay, so I do have confidence that I have my correct. Let me do that as 2 lines because that did not look good. All right, there and there. Okay, so this is the entire graph when x is less than 0. Moving on to the next section, we got 0, -2. I'm going to put a dot here because 0 is a part of it. 0 is less than or equal to x. Okay, 1 goes to -1, and then 2 goes to 0. And again, these are all going to get dots because it is less than or equal to and less than or equal to. Okay, so those are going to get, it is absolute value, but they're just going to be a straight line here. I can connect those two now. And for my last one, when it's greater than 2. Now, again, it is greater than 2. So when I plot this point here, it's not part of this graph. So it's got to be a hole in the graph. So I've got 2, 2. So I'll get a hole there. Got 3, 3. And we got 6, 4. So 1, 2, 1, 2, 3, 4, 5, 6, 4. Now, if you recognize what shape we have here, we have a square root function. It's going to be just very roughly like this. Okay, so that is our basic way of graphing this. You don't have to color code it, but it might be helpful to see the 3 different functions as they work through. Okay, so when I move on to the next section, I'm going to have it set up the same way. Another example. I'll go through this one a little bit quicker. Okay, so same thing. I got my critical values. I got them at -1 and +2 now. So I need to find some values that work in all those spots. Okay, so for -3, and I do that here. -3 plus 1 is a -2. -2 squared is 4. Okay, if I plug a -2 in, that's -2 plus 1 is -1. -1 squared is 1. When I plug a -1 in, now again, we don't need that we need it to help us with the modeling. We don't want it for everything else though. So I'm still going to put the number in here. So -1 plus 1 is 0. 0 squared is 0. And that's it for this column. That one's done. We'll go right into the next section. Okay, -3 does not exist here. -2 does not exist, but -1 does exist in the middle one. Okay, so -1 squared minus 2. So -1 squared is +1. Minus 2 is a -1. Okay, and so we'll go down there. 0 squared is 0. Minus 2 is a -2. 1 squared is 1. Minus 2 is a -1. 2 squared is a part of it still. So 2 squared is 4. Minus 2 is 2. Okay, 3 and 6 do not exist here. So we're going to go ahead and scratch that out and be done. Okay, this one doesn't exist all the way down until I get to 2, my critical value there. Okay, so we will put 2 in there. I take 2 minus 2 is 0. Square root of that is 0. Put a 3 in. 3 minus 2 is 1. Square root of that is 1. Then 6 minus 2 is 4. Square root of that is 2. So got everything I need for my graphing. So go back and start plotting those points. So I got -3, 4, 2, 3, 1, 2, 3, 4, -2, 1, and -1, 0. Now this is a quadratic. So I know that based on this transformation, it's going to look roughly like this overall, but I only care about it. Whoops, just realized I put a closed dot there. Do an open dot. Okay, so that's going to go like this to create that half of a quadratic shape. All right, x squared minus 2. Again, this is my parent function. Minus 2 means it's going to go down 2, but I'm going to plot my other points first. So I've got, let's see here, -1, -1. And that is a part of this function. So I'll do a closed dot, 0, -2, 1, -1, and then 2, 2. Okay, and that gets its own closed dot there as well. And for my final one, and then this one, again, it is greater than 2, so it's not actually part of it, but I got to model it. So that's going to start by going 2, 0, right there. And then it's going to go 3, 1, and 1, 2, 3, wait, 1, 2, 3, 4, 5, 6, 2. And there's my rough shape for my quadratic. All right. So a little bit quicker on that one. That's what we're looking for there. Make sure you do your critical values. You're going to go where it crosses from one to the other, like that, and like that one there. But everything else, it only gets 1 value per spot. All right. So Let's talk a little bit more about transformations. But when we look at this function here, y equals 2x squared minus 12x plus 17, that's very difficult to understand our transformations without graphing it. So instead, we are going to complete the square for this because it's a quadratic. So we can get into this form, and then we can say, hey, how is it transformed compared to y equals x squared? Okay, so we'll start with this. We got y equals 2x squared minus 12x plus 17. Normally, when I do completing the square, I like to focus on the x squared and x terms. So I'll say y equals 2x squared minus 12x. I'm going to put a plus. I'm going to do a plus 17 over here. I didn't need to write that again. Let's just get rid of that. What I'm going to do is I'm going to focus on just these two. Okay. Completing the square is difficult with a 2 in front of the x squared. So instead, I'm going to factor out a 2. I'm just going to do it from the 2x squared and the negative 12x. We're going to have a 2 here, and we're going to have x squared minus 6x when I factor it out there. But I'm going to put a plus blank here for now. And then over here, I'm going to have the plus 17 outside the parentheses. I don't want to factor a 2 out of that. But then I'm going to do another plus blank. Now remember, completing a square means I'm going to take this middle term right here, the 6. We're going to do this idea here. The c value is going to be b divided by 2 squared. So b is negative 6 here. Negative 6 divided by 2, and then I square that. That's going to give me my c value that can complete the square. So negative 6 divided by 2 is a negative 3. Squaring that, I get a positive 9. So I get to put a 9 here. Now, to help balance that out with our equation, I got to put something right here to make sure that it doesn't change the original function. Don't forget, this is a 2 times 9 is 18. So what I'm going to do is I'm going to put a negative 18 here to make it balance. Okay. Now I can factor this. X squared minus 6x plus 9. It factors into x minus 3 squared. 17 plus a negative 18 is going to give me a negative 1. So that's my completing the square. These two functions are equivalent. It's just they're in a different form. So transformations, I've got 3 things going on. Here's my h, my k, and my a value. So I like to start it from inside the parentheses, work it out. So we'll go h, a, and then k in our description. So because it's a negative 3 inside, this graph is going to horizontally translate right 3. Then, because of the 2, it's going to vertically stretch by 2. And then to finish it off, because the k is a negative 1, is going to vertically, horizontally, there we go, vertically translate down 1. Okay, so that's what we're looking at. We're going to take a standard form quadratic, use completing the square to turn into our vertex form. Then we can analyze our transformations. Okay, so let's do that with one more example, and that's going to be dealing with a word problem like this. So the wild ride roller coaster has a section that is shaped like the function g of x equals negative x squared over 30 plus 10x over 3 minus 100 over 3, where g of x is the vertical distance in yards the roller coaster track is from the ground, and x is the horizontal distance in yards from the start of the ride. Describe the transformations. Again, you could graph it. Problem with that is it's difficult to see some of these transformations with, is there a vertical stretch? Is there or a vertical or horizontal, horizontal translation? And like really nailing down where those points are, it can be a little bit tricky. So instead, we're going to go ahead and do completing the square. All right. So I'm going to hang another page here real quick. So my original function, pull that up again. We have g of x is negative x squared over 30 plus 10x over 3 minus 100 over 3. Now, I don't like working with the fractions like this. They're a little bit ugly for the scenario. So here's what we're going to do. I'm going to multiply both sides by 30. Also going to multiply by a negative number because we don't want x squared to be negative. So we're going to take this whole function and multiply by a negative 30. Okay, so I'll have negative 30 times g of x. This will be gone, and it'll turn into a positive x squared. Okay, this will be gone, but then I'm going to have 10x times a negative 10, so it'll be a negative 100x. And then I'm going to get rid of this one, and then I'm going to have negative 100 times a negative 10 there. So that's going to give me a positive 1,000. Now it's set up for a completing the square. So just like last time, it's a little bit easier because I can do x squared minus 100x plus, go ahead and do that, negative 100 divided by 2 and squaring it. So I do that, that's going to be negative 100 divided by 2 is negative 50. And then negative 50 squared is going to give me 2,500. Okay, but I got to do the plus 1,000 and then minus 2,500 as well. All right, so I'll leave the negative 30 times g of x. We can now complete this. It's going to be x minus 50 squared plus up minus 1,500. Now, I still need that a value. I don't like the negative 30, so everything is going to be divided by a negative 30 here. So what I get is g of x is going to be, we can do it as just a fraction, negative 1 over 30 times x minus 50 squared plus 50. Right, let me just double check that real fast. Yeah. All right, so what that means, here's my new function. This is my completing the square version. It's in vertex form. I can now analyze that. The graph is translated 50 units to the right. It is compressed vertically by a factor of like 1/30. Because it's a negative, it's reflected in the x-axis, and then it's translated 50 units up. So remember what I said, it was negative 1 over 30 times x, minus 50 squared plus 50. So 50 units to the right, that's thanks to this part. It is compressed vertically. It's the fraction 1 over 30 because it's less than 1. And it's reflected because it's a negative, and then it goes 50 units up because of the plus 50 at the end. Okay, so just a little bit more complicated, but still the same idea overall. All right, and that's it for today. We have our piecewise functions, graphing those, as well as analyzing our transformations after we do our completing the square. All right, that's it for today. Take care, everybody.